Today, we're building a hibernation cave for the tortoise, providing a sufficiently cool environment for its winter dormancy. But first, let's take a look at the supplies I have ready. I have a piece of plywood and a piece of well-worn aluminum sheet. From the scrap box, I also found a Peltier element. First, I need to mark the removable area on the plywood. I apply painter's tape to prevent surface chipping when cutting with a jigsaw. The jigsaw tears the sheet from the top, and the tape keeps the edge clean. I draw the cutting line with a marker for better visibility beneath the sawdust. That was cut quickly. Let's start opening the Peltier cooling unit. This is a cooler from an old Coca-Cola mini fridge. All old wires and glues must be removed. I take out the element, clean it, attach it back to the center, and add a large aluminum sheet on the cooling side. All electrical connections and wires need to be replaced. The Coca-Cola mini fridge operates on a 5-volt USB power supply, but this Peltier element, as far as I understand, works with a 12-volt voltage. When researching online, I couldn't find anything other than 12-volt Peltier elements, so this one must be as well. However, they vary in power, with the smallest being 3 amps and the largest 15 amps. Additionally, I need a step-down voltage converter for the fan. The fan probably won't withstand over 5 volts. I also want to keep the rotation speed low so that the tortoise isn't disturbed by the fan noise. I have a box full of various step-up and step-down converters. They are always needed when combining different modules or devices. This module's voltage is adjustable, and I can set the voltage after assembling the device. By testing and experimenting, I'll find a suitable speed that cools adequately without the fan noise being too disturbing for the tortoise. This is a quite experimental project. I don't know if the cooling power is sufficient. The idea is that the tortoise can decide when to go into hibernation when there's a cool cave available for it to enter. On the other hand, it's possible that the natural survival instinct guides the animal to move from a colder place to a warmer one. Even though winter dormancy is good for the tortoise, it may not voluntarily want to go into the cold because it's uncomfortable. This is something that will be revealed when the cave is ready, and we'll see how the tortoise chooses. To efficiently transfer heat from the Peltier element, I apply thermal paste between the element and the cooling fin. I notice that the element easily slides on top of the thermal paste. I secure it in place with UV glue on the wires. This way, it stays in place until I screw the cooling plate on. Then it stays between 2 aluminum pieces in compression. Using toothpicks, I can guide the plate to the right place so that the thermal paste doesn't spread everywhere. As I mentioned earlier, the power of Peltier elements can range from 3 amps to 15. I assume this specific element is the smallest, with a rating of 3 amps, as it comes from a mini fridge designed for a single can of Coca-Cola. Next, I clean the edges so that I can attach the aluminum cooling plate to the plywood with double-sided tape. By the way, this tape is ordered from China and surprisingly good. It's probably a copy of 3M or the real thing manufactured in Chinese factories. Initially, it seems like the glue doesn't adhere properly, but it still forms a permanent and durable connection. Parts can be removed later if needed, and the tape comes off easily without leaving marks. Unbelievable stuff, this gray tape. I order it from China, and I always have it in stock. Finally, I add a piece of insulation cut from a foam sleeping pad so that the cooling power is directed only downwards. Now, let's see how Maori is doing. Maori has been in the cave for 3 weeks now, not eating or basking under the lamp. It's probably time to put him into hibernation. The new cover was just the right size. I have measured it correctly. Let's put a couple of stones as weights and then connect the power supply. As you can see, it consumes 2.4 amps at 12 volts, which is about 30 watts of power. I suspect it's not enough to cool the cave sufficiently to a temperature of 3 to 6 degrees Celsius. But at least it provides a cooler place to prepare for actual hibernation, which will take place in the refrigerator. Maori has his own refrigerator for this purpose, where he'll hibernate undisturbed as the fridge won't be open constantly. The power of the Peltier element is not sufficient. The prototype needs improvement, but for now, let's use it like this and put Maori later into the fridge for the real hibernation. Thank you for watching. Remember to like and subscribe to the channel if you enjoyed what you saw. It helps maintain the channel, and I can continue creating new content in the future.